Tonight, we are going to look at Saturn. Not the data, not the catalogue of moons, not the mission history. We are going to look at what Saturn actually is, underneath the image that humans have been staring at through telescopes for 4 centuries. Because the image is not the planet. Saturn looks peaceful from Earth. It has always looked peaceful. A pale golden circle, perfectly ringed, floating quietly at the edge of the visible solar system. The kind of object that makes people stop and point when they first see it through a lens. But the peace is a distance effect. Under those rings there is no surface to stand on. The atmosphere moves faster than anything on Earth has ever moved. The rings themselves are not permanent. They are draining into the planet right now, slowly, continuously, and by some estimates they will be completely gone within a few 100 million years. The thing that made Saturn recognizable may be temporary, and what is underneath it may be stranger than anything the image suggested. By the end of tonight, you will understand why the most beautiful planet in the solar system may also be the most violent, why the rings are not decoration but evidence of something destroyed, and why the calm you see when you look at Saturn was never really there. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It is a simple action, but it helps this channel reach more curious minds like yours. Now let us begin. There is a particular moment that happens for a lot of people the first time they look at Saturn through a telescope. The planet is small. It is always smaller than you expect. But the ring is there, tilted just slightly, catching light in a way that does not look like a photograph or a rendering. It looks real. It looks like a physical thing hanging in the sky. And for a moment, the size does not matter, because what you are looking at is unmistakably itself. There is nothing else in the sky that looks like Saturn. That image has stayed with us. It is in school textbooks, in science posters, on the walls of children's rooms. Saturn is the planet with the ring, the elegant one, the one that looks like something designed rather than something that formed. People who have never touched a telescope recognize it instantly. Ask someone to draw the solar system from memory and the most distinctive shape they produce. The one with no ambiguity is Saturn with its ring. Other planets need labels. Saturn is the one you know by silhouette. And that recognition is exactly where the misunderstanding begins. The image of Saturn that most people carry is an image built from distance. From more than 1 billion kilometers away, the planet is reduced to a point of light with a faint ellipse around it. At that distance, the atmosphere cannot be seen. The temperature cannot be felt. The motion cannot be tracked. What reaches us is light, reflected off ice and cloud, organized by perspective into something that looks calm. Distance is a very effective filter. It removes violence. It removes scale. It removes motion. It takes a planet with no solid surface, winds that exceed anything in Earth's weather system, and rings made from material that was once part of something larger, and it turns all of that into a glowing oval that people find beautiful. Distance does not lie. It emits. And what it emits in Saturn's case is almost everything that Saturn actually is. The beauty is real. That part is not an illusion. But the calm is. This is the first thing you need to understand about Saturn. The image is not wrong, but it is incomplete. What you see from Earth is a very small slice of what Saturn is. The rest of it, the parts that distance hides, are what this story is about. And the distance hides quite a lot. Saturn has no surface. Not in the way that Earth has a surface, or Mars, or even the Moon. There is no ground beneath those clouds. If you descended into Saturn's atmosphere, you would not eventually hit rock or ice. You would move through pressure gradients that become more extreme with depth, until the gas around you stopped behaving like gas entirely, and the pressure became the only reality. The planet is not hollow. It is just that the inside of it has nothing you could stand on. The winds in Saturn's upper atmosphere reach speeds that have no Earth equivalent. Not a comparison to a strong storm, not a comparison to a tornado. The comparison breaks down because Saturn's equatorial winds are not a storm, they are the planet's ordinary atmospheric motion. The baseline. What Saturn's atmosphere does when nothing unusual is happening. And the rings, which look so permanent and so placed in the sky, are moving. Every particle in those rings is in its own individual orbit around Saturn. The smooth, flat surface you see through a telescope is an illusion of scale. Up close, the rings are a field of drifting ice and rock, each piece following its own path, colliding slowly over time, gradually losing energy and gradually draining toward the planet below. None of this is visible from Earth. None of it was obvious until spacecraft got close enough to measure it directly. And even then, what the measurements revealed was not simply surprising. It was a complete revision of what the image had always suggested. The telescope image is where this story begins, but what the image is actually showing is something it cannot contain. The peaceful oval in the eyepiece is a distance effect so complete that it hides an atmosphere of permanent catastrophe, an interior that converts matter into states unknown on Earth, and a ring system that is the organized wreckage of things that no longer exist. The image also carries something that no single photograph of Saturn captures well: the planet's relationship with time. Saturn has been there, in roughly this configuration, for longer than complex life existed on Earth. When the first fish appeared in Earth's oceans, Saturn was already glowing in the outer solar system, already ringed, already running its storms. When the first forests covered the land, Saturn was there. When the first dinosaurs appeared and disappeared, and the continents shifted, and the oceans changed their shapes, Saturn continued its slow orbit, 29 years to complete one lap around the Sun, the rings glowing as they do now, and yet what we know about Saturn is recent. The first telescope view came only a few centuries ago. The first spacecraft photographs came within living memory. The understanding of what the rings are made of, what the atmosphere contains, what the interior does, these are discoveries of the last few decades. We have had the image for centuries. We have understood the image for almost no time at all. That gap between familiarity and understanding is where this story lives. Consider also what the image does not show in terms of time. The light reaching your eye from Saturn left the planet roughly 80 minutes ago. What you see in the telescope is not Saturn as it is now. It is Saturn as it was an hour and 20 minutes in the past. In the time it took that light to travel from Saturn to Earth, storms on Saturn have shifted position. Ring particles have completed small arcs of their orbits. The atmosphere has moved. The hexagon has rotated by a measurable amount. The Saturn you are looking at does not exist anymore in the form your eye is receiving. This is a small thing, cosmically speaking. Saturn is relatively close as astronomical distances go, but it adds one more layer to the gap between the image and the object. The image is not only reduced by distance, it is delayed by time. What looks still is both compressed and late. The planet you are watching is already different from the one you are seeing, and this is the closest major planet to Earth in the outer solar system. For bodies further out, the light delay grows. For Voyager 1, currently in interstellar space, signals take more than 20 hours to arrive. The universe does not allow observation of distant things in real time. Every image is a memory of something that has already changed. All of that is there. It has always been there. Right behind the image that everyone finds beautiful. The first thing distance hides is scale. When you look at Saturn through a telescope, your eye does something automatic. It reads the rings as a frame, the planet as an object inside that frame, and it assigns the whole thing a size that feels proportional to how bright it is and how small the sky appears around it. The brain is doing its best with the available information, but the brain is wrong. Not slightly wrong, categorically wrong. Saturn is not large in the way that word usually works. It is not the large of a tall building or a wide ocean or even a continent. It occupies a different category of size entirely. One that has no everyday equivalent, and that does not translate easily into a felt sense of anything a human has experienced. Here is one way to approach it. If Earth were the size of a grape, Saturn would be roughly the size of a basketball. That comparison sounds manageable at first. A basketball is bigger than a grape. Fine, but hold that image a moment longer. A basketball is not a little bigger than a grape. The ratio between them is not a rounding difference. It is a categorical gap. You could hold both in your hands and feel immediately how different they are in volume. And then remember that the basketball in this comparison is not rock. It is not ice. It is gas, held in a sphere by its own gravity, with no solid floor inside it anywhere. The interior of that basketball is a graduated compression system hundreds of thousands of kilometers deep, getting hotter and denser the further you go in, until the gas stops behaving like gas and becomes something else entirely. Saturn could contain roughly 760 Earths inside its volume. That number is not meant to impress. Numbers like that rarely land as felt reality. What it is meant to do is frame everything that comes after it. Because the behaviour of Saturn, every strange thing about it, every violent thing, every feature that this story is building toward, comes from that scale. Scale is not a background detail here. It is the engine. It is the reason for everything. A planet that large has gravity that does not simply pull nearby objects into orbit and leave them alone. It deforms them. It heats them from the inside. It tears them apart if they come too close. It converts the behaviour of ordinary matter inside itself into states that have no surface-level equivalent anywhere in human experience. Every chapter that follows this one is a consequence of Saturn being the size it is. The rings exist because of that scale. The storms exist because of that scale. The interior behaviour exists because of that scale. The moons that orbit on the outer edges, being slowly heated and pulled and reshaped over billions of years, are in the condition they are in because of that scale. But there is one more layer to the size question that does not often come up when Saturn is described in passing, and it complicates the impression further. Saturn is lighter than you would expect something that large to be. Not lighter in absolute mass. In absolute mass, Saturn is enormous, roughly 95 times the mass of Earth. But if you measured the average density of Saturn across its entire volume and compared it to the density of water, the water would be denser. Saturn's average density is lower than that of water. It is the only planet in the solar system for which this is true. If you could build a bathtub large enough to hold it, Saturn would float. That seems at first like a minor or even amusing fact. It is not minor. It tells you something important about what Saturn is made of and how that material is organised. Saturn is not a compact compressed object with weight proportional to its size. It is mostly volume, mostly gas. Mostly material that, averaged across its entire enormous extent, is less dense than the liquid that fills Earth's oceans. The mass is real and the gravity is real, But the thing producing that gravity is not the kind of solid, dense material that makes other planets feel imposing. Saturn is enormous and relatively diffuse, held together by its own rotation and the inward pressure of all that distributed mass. That kind of object does not behave the way a rocky planet behaves. It does not have a surface to organize its weather around. It does not have terrain to slow its winds. It does not have a coastline or a mountain range to redirect atmospheric flow. It does not have a friction boundary between the atmosphere and the ground, because there is no ground. What it has instead is depth. And depth on a planet this large is not like depth on a rocky world. On Earth you can drill down until you hit the limit of technology and then extrapolate from what the seismic data shows. On Saturn, depth means layers of changing physics, each one more alien than the one above it, with no moment of arrival at anything familiar. No center you could recognize, no bottom you could touch. There is another way to feel the scale that the comparison does not capture. Saturn's equatorial diameter is roughly 9.5 times Earth's, not 9.5 times the area. 9.5 times the diameter. Area scales as the square of diameter, volume as the cube. A planet with 9.5 times the diameter of Earth has not 9.5 times Earth's volume. It has more than 700 times Earth's volume. That is the difference between a linear measurement and a volumetric one. The number 9.5 sounds manageable. What it produces in 3 dimensions does not. And all of that volume is gas. Not rock. Not ice. Gas and liquid that has been compressed by gravity into the form of a planet. The material is the same material you find in stars, the same material you find drifting between galaxies in thin clouds. Under enough gravitational force, that material takes the shape of a planet. Saturn is, in some meaningful sense, a failed star. Not massive enough to ignite, but massive enough to organize all that gas into a sphere and maintain it there for billions of years. That is what the glowing oval in the telescope is. Think about what it means to be the only planet in the solar system lighter than water. Every other planet, including the gas giant Jupiter, has an average density greater than water. Some, like Earth and Mercury, are very dense indeed, composed largely of iron and rock pressed tightly together by their own gravity. Even Jupiter, which is also primarily hydrogen and helium, is dense enough to be heavier than water on average because its much greater mass produces much greater interior compression. Saturn is the exception. Its mass is not enough to compress its hydrogen to the density of water across the whole volume. The outer layers, the enormous volume of gas in the upper atmosphere and the hydrogen layers below, are light enough that they pull the average density below water's threshold. What this also means is that Saturn, for all its enormous size, contains relatively little mass compared to what you might expect from something that large. Jupiter has more than 3 times Saturn's mass, despite being only about 20% larger in diameter. Saturn's bulk is genuine, but its substance is thin. It is a vast, diffuse envelope of hydrogen and helium held in a sphere by its own gravity, and the sphere is much bigger than the amount of mass inside it would suggest to anyone familiar only with rocky worlds. That diffuseness is part of what makes Saturn's behaviour so unlike anything on Earth. The same mass that would be densely packed in a rocky planet is spread across an enormous volume of gas, and the gas behaves completely differently from rock at every stage of what happens next. The first of those layers is the atmosphere, and the atmosphere is where the distance illusion begins to collapse in the most immediate physical way. There is no floor. This sounds like a simple statement when you hear it. Of course Saturn is a gas giant. Of course it does not have a surface in the traditional sense. Most people have encountered this idea at some point, in a documentary or a science class and absorbed it as a piece of information without fully processing what it means as a physical reality. What it means is this. Think about what a floor does. It stops things. It creates a bottom. It organizes everything above it around the fact that there is a place where descent ends. Every experience of going down, anywhere on Earth or any rocky world, ends with the assumption that something will eventually stop you. The ocean has a floor. The deepest trench in the ocean has a bottom. A cave goes down until it stops. A shaft can be drilled until the rock becomes too resistant. The concept of a floor is so fundamental to physical experience that imagining its genuine absence requires deliberate, sustained effort. It is not something the brain volunteers easily. Saturn has nothing equivalent to this. If you were placed above Saturn's cloud tops and began to descend, you would first enter the visible cloud layers. These clouds are real. They have structure and thickness and variation. They are made of ammonia ice crystals and other compounds that interact with the sunlight reflecting off them to produce Saturn's characteristic pale gold colour. The famous banded appearance of Saturn, the alternating light and dark stripes visible even through modest telescopes, is the upper surface of these cloud systems seen from the outside. But the clouds are not a floor. Beneath the first cloud layer, the gas continues. You would pass through regions of different composition, different temperature, different density. The pressure around you would increase steadily. The light from above would fade. Somewhere below you, more cloud layers would appear and then be passed through in turn. The environment would get heavier and hotter and darker, and none of this would have an endpoint that a physical object could recognize as arrival. There is no moment where the atmosphere ends and the planet begins. The atmosphere is the planet. They are the same continuous body of material, organized by gravity and pressure into layers that become more extreme as you descend, with no dividing line between them. At a depth of perhaps 100 kilometers below the visible cloud tops, the pressure has increased to levels that would exceed the structural tolerances of any spacecraft human engineers have designed for planetary entry. Not dramatically or all at once, but relentlessly and completely. The materials we use to explore harsh environments, designed to withstand enormous external forces, would simply be overwhelmed by the weight of the atmosphere above them. Keep descending. The temperature rises. The pressure increases by orders of magnitude compared to Earth's surface. The gas becomes denser and denser, and the transition from what could reasonably be called gas to what could reasonably be called liquid becomes gradual rather than sharp. There is no surface at which that transition occurs. The material just becomes more and more unlike the gas that floated near the top. It transitions continuously through intermediate states towards something more extreme. And deeper still, something qualitatively different begins to happen. The physics of the material changes in ways that have no surface equivalent, but that belongs to a later chapter. The important point here is simpler and more disorienting than the physics. If you descended into Saturn, there would be no moment of arrival, no thud, no landing, no touching of anything that would register as solid, just a continuous transition from one state of matter to another, each state more alien than the one before it, in an environment that was never structured to have an inside edge a physical object could recognize. The planet has no bottom in any experiential sense, and this absence has a direct consequence for everything above it. An atmosphere without a floor to push against behaves differently from an atmosphere with one. The absence of terrain, of friction boundaries, of anything to interrupt atmospheric flow from below, means that the energy in Saturn's atmosphere has nowhere to go except back into the atmosphere itself. It circulates, it builds, it sustains speeds that would only be possible on Earth as brief, extreme, localized events. Saturn's atmosphere is free to move in a way that Earth's atmosphere never is. There is a specific quality to the absence of a flaw that changes how you have to think about everything Saturn does. On Earth, the atmosphere is a layer sitting on top of a solid object. The solid object is what matters in most cases. The atmosphere is the weather system that happens above it. The distinction between planet and atmosphere is clear and physical, and something you can touch. On Saturn, there is no such distinction. The atmosphere is not a layer on top of something. The atmosphere is the thing itself. When scientists talk about what Saturn is made of, they are talking about the atmosphere. When they talk about what Saturn looks like from above, they are talking about the atmosphere. When they talk about Saturn's interior, they are talking about the deeper layers of the atmosphere, compressed and heated and transformed beyond recognition, but continuous with the clouds visible from Earth. Saturn is atmosphere all the way down. That is a strange sentence to sit with. But it is what a gas giant is. And what a gas giant does with that structure is something that a planet with a flaw cannot do. The comparison to an ocean floor is worth taking further. Earth's deepest ocean trench, the Mariana Trench, reaches roughly 11 kilometers below sea level. At that depth, the pressure is about 1,000 times the atmospheric pressure at sea level. That pressure is enough to crush most objects not specifically designed to withstand it. The handful of craft that have reached that depth are engineering achievements built specifically for that environment. At equivalent depths in Saturn's atmosphere, even before reaching the layers where the physics of the material itself changes, the pressure exceeds anything the Mariana Trench produces by many orders of magnitude. Not twice the Mariana pressure, not 10 times, by factors of millions. The comparison to deep ocean is not adequate. There is no surface experience adequate to what Saturn's interior does to pressure. This is one of the things that makes Saturn genuinely difficult to study. We cannot send instruments into it that would survive long enough to return data from deep inside. The Pioneer and Voyager spacecraft flew past. Cassini orbited but could not descend. The only mission that has attempted to enter a gas giant's atmosphere was the Galileo probe at Jupiter, which survived for roughly an hour of descent before being destroyed by pressure and heat. Saturn's interior is directly inaccessible with current technology, and likely with any technology that can realistically be built in the near future. What we know about Saturn's interior comes from models, from the planet's gravitational field, from its magnetic field, and from what physics predicts happens to hydrogen and helium under extreme conditions. The models are well grounded in physics, but they are models. The interior of Saturn is, in a meaningful sense, still beyond our direct reach, and what it does with that freedom, even in its most ordinary state, is something Earth's atmosphere could not match. Saturn's atmosphere has a resting state, not a calm state, a resting state. The difference matters more than it might initially seem. On Earth, calm weather is a real condition. The atmosphere can be genuinely quiet. Wind speeds drop to near zero. Pressure stabilizes across wide regions. The air above a city on a still morning is doing very little. Calm, in the meteorological sense, is a measurable, real state that Earth's atmosphere achieves regularly, and that people experience directly as stillness. Leaves do not move. Smoke rises in a straight column. The word calm describes something that actually exists in Earth's atmospheric behaviour. On Saturn, no equivalent of this exists. The closest thing to Saturn's atmospheric calm is a permanent, continuous motion that would register, on Earth, as a catastrophic weather event beyond any that has been recorded in human history. Not an unusually bad storm, not a once-in-a-generation hurricane, something beyond any category Earth's meteorologists have needed to define. Because nothing equivalent has occurred within the span of human measurement. The equatorial winds on Saturn move at roughly 1,800 km per hour. Sit with that number for a moment before reaching for a comparison. The fastest surface wind speed ever reliably recorded on Earth is somewhere around 400 km per hour. That measurement came from an extreme weather event at a specific location under specific conditions for a brief period. At that speed, the event is treated as a dangerous anomaly. Structures are destroyed, trees are removed. People who survive it describe it as unlike anything they experienced before. That speed sits at the extreme outer edge of what Earth's atmosphere is capable of producing. Saturn's equatorial winds are more than 4 times that speed. They extend across the entire equatorial region of a planet that could contain 760 Earths by volume. They are not a localized event. They are not exceptional or unusual. They are the normal, continuous, ongoing motion of Saturn's equatorial atmosphere, present every hour of every day, and they have been at this speed for as long as any instrument has been close enough to measure them. Why does this happen? The answer requires thinking about what slows Earth's atmosphere down and then removing all of it. On Earth, wind is constantly being impeded. Mountain ranges redirect airflow and create turbulence that bleeds off energy. Forests create friction at the lowest level of the atmosphere, dragging on moving air and converting its momentum into heat and disruption. Oceans exchange heat unevenly with the atmosphere and create pressure differences that disrupt large-scale circulation patterns. The topography of Earth, the valleys and plains and coastlines and ice caps, continuously interacts with the atmosphere and gradually dissipates its energy. Earth's atmosphere is in a constant negotiation with the surface beneath it. Energy flows in from the sun and gets distributed and dissipated by the surface continuously. Saturn has no surface beneath it. There is no terrain, no friction boundary, no mountain to force atmospheric flow upward and disrupt it. The atmosphere of Saturn sits above more atmosphere, descending without interruption to depths we cannot directly observe, and the energy that drives the upper winds has nothing below it to absorb or redirect it. The energy circulates, it builds. The jet streams that form in Saturn's atmosphere have been running, largely uninterrupted by anything beneath them, for timescales that dwarf any weather pattern Earth has ever produced. The result is an equatorial jet stream that is not a weather event. It is a permanent feature of the planet's atmospheric character. Not weather on a planet. The weather is the planet. And this is the baseline. This is Saturn doing nothing unusual. Above this baseline, there is additional structure. The visible banded appearance of Saturn, the alternating pale and dark stripes, is the visual signature of different atmospheric bands moving at different speeds and in different directions. Where adjacent bands with different velocities meet, there is a boundary zone. At that boundary, faster air pulls against slower air. The velocity difference creates shear. The shear generates turbulence. The turbulence, given the right conditions, organizes into storms. Storms on Saturn are not aberrations. They are natural products of the atmospheric architecture. The basic structure of the planet, the bands, the jet streams, the persistent temperature gradients between different latitudes, already contains within it everything needed for storm formation. Saturn does not need an unusual event to produce extreme weather. The baseline state is already structured to generate it. There is something worth pausing on in the phrase ordinary atmospheric motion. On Earth, weather is the exception. Most of the time, over most of the planet, the atmosphere is doing very little. The day-to-day experience of being on Earth's surface involves a mostly quiet atmosphere that occasionally produces wind and rain, and rarely extreme events. The extreme events are the news. The ordinary state is the background. On Saturn, what Earth would call an extreme event is the background. The 1,100 km/h equatorial wind is not the weather. It is the absence of weather, in the sense that it is the state the atmosphere returns to when nothing unusual is disrupting it. The storms that form on top of this baseline are events on top of an already extreme background. This means that the atmospheric violence on Saturn is not something that happens to the planet occasionally. It is a property of the planet's basic state. Saturn is not a calm world with violent weather. Saturn is a violent world whose calmest moments would be the worst weather ever recorded on Earth. That reframes what it means to look at it through a telescope and see something still. There is a further implication of the permanent wind speed that is worth naming directly. Earth's most destructive weather events, hurricanes and typhoons, get their energy from the ocean surface. Warm water evaporates. The vapor rises. It releases heat as it condenses into clouds. That released heat powers the circulation of the storm. Remove the warm ocean and the storm weakens. Cut off the energy supply and the storm eventually dies. Saturn's equatorial jet stream has no ocean beneath it to cut off. It has no energy supply that can be interrupted by changing conditions at the surface, because there is no surface. The heat driving the jet stream comes from Saturn's interior, rising continuously from the helium rain and the residual formation energy below. That interior heat source is not dependent on season or on the sun's position or on surface temperature changes. It is deep, stable, and continuous. This means Saturn's equatorial winds cannot be weakened the way Earth's most powerful storms can be weakened. There is no mechanism that would cause them to slow to Earth hurricane speeds, let alone to Earth calm speeds. The wind is not a feature of Saturn's weather. It is a feature of Saturn's physics. A structure placed in that wind would not be experiencing weather. It would be experiencing the basic operating condition of the planet. The wind is not something Saturn does sometimes. It is something Saturn is. And that structure, in one specific place at Saturn's North Pole, does something with the atmosphere that the solar system produces almost nowhere else. If you looked at Saturn's North Pole from directly above, you would see something that the brain does not easily categorize. Not a spiral, not an oval, not the circular storm system that the poles of other planets produce when atmospheric dynamics organize around a rotation axis. Something with straight edges, something with corners, 6 of them, arranged with near-perfect symmetry, each side of approximately equal length, the whole structure rotating steadily around the pole. A hexagon, a 6-sided geometric structure at Saturn's North Pole, rotating with the planet, each side measuring roughly 13,800 kilometers in length. Each side is longer than Earth's total diameter. The structure contains a rotating storm system at its center. It has been observed since the Voyager spacecraft first returned images clear enough to identify it. It was still there, unchanged in its fundamental shape, when the Cassini spacecraft arrived decades later and spent years documenting it in different wavelengths, different lighting conditions, and from different orbital geometries. It has not dissolved. It has not drifted from the pole. It has not simplified into the spiral or oval that most intuitions about atmospheric dynamics would predict. It was not put there by any external process. Nothing constructed it. It formed from the fluid dynamics of a rotating gas atmosphere at a specific polar latitude, and it remains because the same physics that produced it continues to maintain it. When scientists first saw images clear enough to identify what the feature was, there was a period of careful examination. Hexagons do not appear in planetary atmospheres. Polygons in general do not appear in planetary atmospheres. When fluids and gases move in rotating systems at large scales, they produce curves. Spirals, ovals, banding, the geometry of large-scale fluid dynamics, the kind produced by rotation acting on fluid over time, is almost always curved. Rotation favours circular and spiral structures, because circular motion is how rotating systems naturally evolve. The hexagon is not curved. The explanation, developed over years of atmospheric research and laboratory experiments with rotating fluid tanks, involves a concept called a standing wave. In Saturn's polar atmosphere, a wave pattern in the polar jet stream has reached a stable resonant state. Rather than propagating around the pole and gradually dissipating, the wave pattern reinforces itself. The number of wave crests that fit around the pole at that latitude, given Saturn's rotation rate and the atmospheric conditions present, happens to be 6. 6 crests produce 6 nodes, and 6 nodes produce a 6-sided pattern. The stability of the resonance is what keeps those 6 sides from collapsing into a simpler shape over time. This same type of behaviour has been demonstrated in laboratory experiments with rotating tanks of fluid. By adjusting the rotation speed and the fluid conditions, researchers have produced polygon patterns including squares, pentagons, and hexagons. The physics is not unique to Saturn. The mechanism is demonstrable and reproducible. Rotating fluids can produce stable polygonal patterns under the right conditions, but knowing the mechanism and having the image feel familiar are different things. The Cassini photographs of Saturn's North Polar hexagon are among the most visually striking images returned by any planetary mission. Seen from above, the structure looks, at first glance and at second glance, more like something engineered than something produced by atmospheric motion. The regularity of the sides, the precision of the angles, the dark rotating storm system at the centre, the entire structure glowing in Saturn's reflected light, enormous and geometrically precise. Each side of the hexagon is roughly the diameter of Earth, measured as one wall of a 6-sided polygon in a gas giant's atmosphere at planetary scale. The storm rotating at its centre is large enough that Earth could fit inside it. Nature produced that with fluid dynamics alone. No template, no external geometry, no structure to form around. Just a rotating gas planet at a specific latitude, producing a stable 6-sided wave pattern in its atmosphere and maintaining it for longer than we have been able to observe. The hexagon is a permanent feature of Saturn's North Polar atmosphere, not a temporary configuration, not a rare event. A standing feature that has been there through every observation we have made since we first had instruments capable of seeing it clearly. The hexagon is also worth considering from the perspective of what it says about Saturn's atmosphere at large scale. On Earth, the atmosphere organises itself in patterns that are fundamentally chaotic at the scale of daily weather. The equations that govern atmospheric motion are sensitive to initial conditions, which means small differences in starting state produce large differences in outcome over time. Weather forecasting on Earth becomes unreliable beyond about 2 weeks precisely because of this sensitivity. Saturn's polar hexagon has been stable in its essential shape for every decade we have been able to observe it. It has not drifted, it has not dissolved, it has not simplified or amplified into something different. It is a stable atmospheric pattern maintained by the same physics that produces it. This tells you something about the consistency of the conditions that maintain it. Saturn's polar atmosphere, despite being made of gas in constant motion at speeds that exceed anything on Earth, produces a feature more geometrically stable and more persistent than any weather pattern Earth has ever generated. The most violent seeming environment produces the most precisely organized result. That is one of the cleaner illustrations of what Saturn actually is. The precision of the hexagon raises a question that the fluid dynamics explanation answers but does not entirely dissolve. If the hexagon is a standing wave maintained by a resonance condition in the polar jet stream, why 6 sides and not 5, or 7, or 8? The answer is that the number of sides depends on the ratio between the jet stream's wind speed and Saturn's rotation rate at that latitude, combined with the physical size of the polar region. The specific combination of conditions at Saturn's north pole happens to produce 6 wave crests fitting around the pole. A planet with a slightly different rotation rate or slightly different polar jet stream speed might produce a pentagon or a heptagon instead. This means Saturn's hexagon is not a universal feature of gas giants. It is a product of Saturn's specific parameters. Jupiter, which is also a gas giant with a rotation axis and a polar region, does not have a hexagon at its poles. Jupiter has oval storm systems. Saturn has a hexagon. The difference comes from the difference in the specific conditions at each planet's polar region. The hexagon is, in this sense, a fingerprint. A geometric signature produced by the precise values of Saturn's atmospheric properties at its north pole. Different planet, different rotation rate, different wind speed, different shape. And that specific shape has been stable for decades of observation, not drifting toward 5 sides or 7 sides. Holding at 6, maintained by the same conditions that produced it, running continuously in an atmosphere that contains some of the most extreme wind speeds in the solar system just a few thousand kilometers away from it. The most violent atmosphere produces the most precise geometry, that is Saturn. And the hexagon is powered not by sunlight, but by energy that rises from deep inside Saturn. The source of that energy is something that changes how the entire planet should be understood. Saturn is farther from the Sun than Jupiter. At that distance, sunlight is weaker. The energy arriving at Saturn per square meter of surface is a small fraction of what reaches Earth, and an even smaller fraction of what powers the inner planets. By the straightforward logic of solar heating, Saturn should be a cold, slow, mostly passive world, a distant sphere of gas, barely energized by the sun it orbits, doing very little with what little solar energy it receives at this distance. That is not what Saturn does. Saturn emits roughly 2.5 times more energy than it receives from the Sun. The math is not complicated. Saturn radiates heat into space. That heat can be measured. And the measured output is substantially larger than what the Sun delivers to Saturn at this orbital distance. Saturn is releasing energy from a source that has nothing to do with the Sun, and releasing more of it than the Sun provides. The source is internal, and it is not nuclear. Saturn does not have the mass to sustain hydrogen fusion the way a star does. The threshold for stellar-scale fusion requires a mass roughly 80 times that of Jupiter, and Saturn is less massive than Jupiter. There are no nuclear reactions happening inside Saturn at scales that would account for the measured energy excess. What is happening inside Saturn is subtler, and in its own way, more significant. To understand it, go back to Saturn's formation. Saturn formed from the same rotating cloud of gas and dust that produced the rest of the solar system roughly 4.5 billion years ago. In the early stages of formation, as material collapsed inward under gravity and the planet's mass grew, the energy released by all that infalling material heated the interior enormously. The early Saturn was much hotter than it is today. Significantly hotter. Hotter in ways that would have been visible from a distance had there been anyone to observe it. Since then, Saturn has been slowly releasing that heat into space. Over billions of years, the excess thermal energy from formation has been gradually escaping. This slow cooling has been ongoing throughout Saturn's history and is still ongoing now. But there is a second process that has extended the cooling timescale and added a separate source of heat. As Saturn cools, its composition changes in a specific way. Saturn is primarily hydrogen, but it also contains helium in significant quantities. Helium is slightly heavier than hydrogen. As the interior of Saturn cools towards certain temperature thresholds, helium becomes less soluble in the surrounding hydrogen layer and begins to separate out. It forms tiny droplets within the hydrogen. Those droplets are denser than the hydrogen around them, so they sink toward the interior. Slowly, continuously, at this very moment, a planet-wide, invisible rain of helium droplets is falling through thousands of kilometers of hydrogen inside Saturn, moving toward the deeper interior. As each helium droplet falls, it releases energy, gravitational potential energy converted into heat by the same basic physics that makes any falling object release energy on impact. On Earth, this process is familiar at small scales. A waterfall releases energy where the water drops. A stone dropped from a height releases its energy on landing. On Saturn, the falling material is helium. The distance it falls is enormous, and the process has been running continuously for billions of years. That heat rises, it drives convection throughout the interior, it warms the outer layers from below, it contributes to the jet streams, it powers the hexagon, it fuels the storm systems. It is the reason Saturn's atmospheric activity does not depend primarily on sunlight. This reframes everything that came before in a significant way. The equatorial winds moving at 1800 kilometers per hour are not primarily solar-driven. They are driven by heat from below, from the helium rain and the residual formation heat still escaping from Saturn's interior. The hexagon at the North Pole is maintained by this internal energy. The storms that form in Saturn's atmosphere, including events large enough to encircle the entire planet, are fueled by an energy source that has nothing to do with Saturn's distance from the Sun. If you moved Saturn to twice its current orbital distance, to a region where sunlight is even weaker and more diffuse, its atmosphere would still be violent. The jet streams would still blow. The hexagon would still sit at the North Pole. The excess internal heat would still escape and drive the circulation. The Sun is a minor contributor to Saturn's atmospheric behavior compared to the planet's own internal energy source. Saturn is largely self-powered. The self-heating of Saturn also changes how the planet fits into the larger context of the solar system. Most planets are, to first approximation, passive in their energy budget. They receive sunlight, absorb some of it, and radiate the rest back into space. Their behavior is driven largely by how much light they receive and how their surfaces and atmospheres process it. They are objects in a solar energy system, acting primarily as recipients and ray emitters. Saturn is not primarily that. Saturn's internal energy source, the helium rain and the residual formation heat, drives its atmospheric behavior more than the Sun does. Saturn is more like a very small, very cold, very faint star in its energy logic than like a rocky planet in its energy logic. It produces energy from its own gravitational processes and radiates that energy outward. The Sun is a secondary input. This places Saturn in an interesting category. It is not a planet the way Earth is a planet, in the sense of a body whose behaviour is largely governed by external solar energy. It is a body that generates much of its own behaviour internally. The result is an atmosphere that would be active even in the dark, even far from the Sun, even without any external energy source driving it. Saturn carries its violence with it wherever it goes. The helium rain also raises a question about how long this process continues. As helium separates from hydrogen and sinks towards Saturn's interior, the ratio of helium to hydrogen in the outer layers gradually decreases. Over billions of years, the outer layers become progressively more depleted of helium relative to their original composition. Eventually, if the process continued long enough, the outer layers would contain very little helium, and the rain would slow as there is less helium available to separate out. Saturn is not yet at that point. Current measurements of Saturn's atmospheric helium content suggest the depletion has been ongoing, but is not complete. There is still helium to separate and sink. The helium rain is still running. The excess heat it generates is still escaping from the planet. But this is a process with a finite timescale. The helium rain will not run forever. At some point in Saturn's deep future, the separation will have proceeded far enough that the rate of helium rain slows significantly. The excess internal heat production decreases, and Saturn begins to cool more rapidly toward the temperature dictated by the sunlight it receives. Saturn's current excess heat output is not a permanent property of the planet, it is a phase. A long phase, running for billions of years and continuing now, but a phase nonetheless. Saturn is, in this sense, still in an active period of its thermal evolution. A billion years from now, or several billion years from now, Saturn will be a cooler, quieter world. Tonight, it is still warm. And what is happening inside it, the interior that produces this continuous heat and drives everything visible from outside, is something that has no equivalent in any ordinary physical experience of matter. Imagine ordinary hydrogen. The gas inside a balloon, the lightest element in the periodic table. One proton, one electron, bound together into the simplest atom that exists. Under normal conditions, the electron stays attached to its proton. The hydrogen atom holds together, it floats upward in air, it conducts no electricity. It does the things hydrogen does at the pressures and temperatures that exist anywhere on Earth's surface. Now increase the pressure, not gradually, not by doubling or tripling it, by millions of times. The kind of pressure that exists inside a planet with Saturn's mass, tens of thousands of kilometers below the cloud tops, where the weight of all the gas above presses inward with a force that has no surface equivalent and no everyday comparison that captures it accurately. Under that pressure, something changes in the hydrogen. The atoms are squeezed so tightly together that the electrons can no longer stay attached to their individual protons. The extreme pressure forces the electrons free from their atoms. They begin to move through the material independently, not bound to any particular proton, flowing from one location to the next. The hydrogen stops being a gas. It stops being a liquid in any ordinary sense. It becomes something that conducts electricity, because electrons are moving freely through it the way they do through copper or aluminum. Hydrogen becomes a metal. This state is called metallic hydrogen. The name is technically accurate in the most precise sense. The freely moving electrons give the material the electrical conductivity that defines metallic behavior. But the name sounds strange, because hydrogen is not what the word metal brings to mind. It is the lightest element, It is the stuff of water. It is what stars fuse into helium. It is what fills weather balloons, and what a human breath is, mostly nitrogen and oxygen, but partly. In every context a person has access to at normal temperatures and pressures, hydrogen is a transparent gas that floats away if you let it. Under enough pressure, it behaves like a metal. Metallic hydrogen does not exist anywhere on Earth's surface. It cannot be produced in any ordinary environment. Laboratory experiments using the most extreme pressure generating equipment ever built for scientific research, devices that can produce pressures millions of times greater than Earth's atmosphere, have managed to produce it briefly, in quantities far too small to see, for fractions of a second before the pressure releases and the hydrogen returns to its ordinary gaseous form. Even under the best experimental conditions, metallic hydrogen is barely accessible and almost impossible to hold or study in any sustained way. Inside Saturn, metallic hydrogen exists in a layer estimated to begin roughly 30,000 kilometers below the visible cloud tops. It has been there for billions of years. It is there right now, as this is being read or listened to, in the dark interior of a planet more than 1 billion kilometers from Earth. Here is what that means physically. When electrically conductive material flows, it generates a magnetic field. This is the same principle that operates in Earth's core, where liquid iron moving in convection currents driven by the temperature difference between the inner and outer core generates Earth's magnetic field. On Saturn, the flowing conductive material is not iron. It is hydrogen, compressed into its metallic state by the weight of the planet above it, rotating with the planet, moving in convection patterns driven by the heat from the helium rain and the residual formation energy below. Saturn's magnetic field is generated by metallic hydrogen. That magnetic field is real, large, and has been directly measured by multiple spacecraft. It is roughly 578 times stronger than Earth's magnetic field. It extends outward from Saturn and creates a magnetosphere, a region of space dominated by Saturn's magnetic influence that stretches millions of kilometers in every direction from the planet. Several of Saturn's moons orbit entirely within this magnetosphere. Charged particles from the Sun are captured and redirected by it. The auroras at Saturn's poles, massive and energetic events, are produced by charged particles following the magnetic field lines down into the atmosphere. All of it begins with hydrogen that has been compressed beyond recognition. Saturn's magnetic field, which shapes the space around the planet for millions of kilometers, which influences every moon in the system, which connects Enceladus's erupting ocean to Saturn's atmospheric chemistry through electromagnetic pathways, is generated by the simplest element in the universe, transformed by pressure alone into something that conducts electricity. That transformation is happening inside the planet right now. It is worth holding the metallic hydrogen concept against what it means for how we understand matter. Matter behaves differently under different conditions. This is a fact of physics that is easy to state and difficult to fully internalize, because the range of conditions available on Earth's surface is narrow compared to what the universe produces. On Earth, hydrogen is a gas. Water is a liquid at room temperature. Iron is a solid. These feel like the natural states of these materials, the states they are in by default, but those states are the states of those materials under Earth conditions. Change the conditions significantly and the materials change. Water becomes ice at low temperature and steam at high temperature. Iron becomes liquid at extreme heat. Hydrogen, under extreme pressure, becomes a metal. The materials are not changing their fundamental identity. Hydrogen under extreme pressure is still made of protons and electrons, but the arrangement and behavior of those components changes completely. The material that results conducts electricity generates magnetic fields, and has properties nothing like what the word hydrogen suggests. Saturn's interior is a reminder that what we call the properties of a material are really the properties of that material under conditions we happen to live in. Under other conditions, other properties emerge. Saturn's interior is a laboratory running experiments that no surface laboratory can replicate. The metallic hydrogen layer also raises an interesting question about how we categorize planets. Jupiter and Saturn are called gas giants. The name made intuitive sense before spacecraft revealed what their interiors might look like. Giant planets made mostly of gas, but the interiors of these planets contain metallic hydrogen, a state of matter that is neither gas nor liquid nor solid in any ordinary sense. They likely also contain a dense core of heavier elements compressed to conditions we cannot reproduce experimentally. What we call a gas giant is more accurately a planet with a thick hydrogen-helium envelope surrounding layers of increasingly exotic matter, topped by what is visible as cloud and atmosphere. The gas giant label describes only the outermost layer, the part that is actually gaseous. The interior is something else. This is not a trivial terminological issue. It reflects the broader challenge of describing things that exist under conditions with no Earth equivalent. The words available for describing matter were developed by people living on a rocky planet under ordinary atmospheric conditions. When matter is compressed to millions of times normal pressure, the words that developed on Earth's surface stop being adequate. Saturn's interior is not a place where language works well. It is a place where the labels break down and the physics takes over. Metallic hydrogen is the best name available for what is there, but metallic hydrogen is ultimately just a name for hydrogen doing something that hydrogen on Earth's surface never does, and that no ordinary experience of hydrogen would suggest was possible. The interior of Saturn is where familiar things become unrecognizable, and the boundary between familiar and unrecognizable is several hundred kilometers below the cloud tops that glow in a telescope. And the most visible product of everything happening inside Saturn, the feature that makes it the most recognizable planet in the sky, is not calm either. It just looks that way from 1 billion kilometers away. The rings are the reason people love Saturn. Among all the planets, Saturn has the most immediate visual identity. Jupiter has its bands and its famous storm, but those require at least a modest telescope to appreciate clearly. Mars is a reddish point. Neptune is invisible to the naked eye. Saturn, even through a small telescope on a clear night, shows you its ring. The first time most people see it clearly, the response is the same. It does not look real. It looks like a model. It looks like something placed there deliberately by someone for someone to find. That impression, the sense of something carefully arranged, is part of why the rings feel permanent. Something that looks that purposeful does not feel like an accident or a temporary configuration. It feels like a defining characteristic, as permanent as the planet's mass or its orbit. The rings are not permanent. They are a debris field. Each of Saturn's main rings is made of billions of individual particles. Ice, mostly, some particles are tiny, smaller than a grain of sand. Others are chunks the size of a house or larger. Each of them is in its own individual orbit around Saturn, following its own precise path, governed by Saturn's gravity and by the subtle gravitational influences of nearby moons, and by the slow cumulative effects of interactions between neighbouring particles over millions of years. The smooth, flat, luminous surface you see in photographs does not exist up close. If you were inside Saturn's main ring system, you would not be standing on anything. You would be floating in a field of slowly drifting objects, most of them individually invisible, too small and too far apart from any close vantage point to see as distinct objects. some large enough to identify clearly but separated by enough empty space that the environment would feel more like a sparse debris field than the solid disk the photographs suggest. The density of the ring material, experienced from within, is far less than a snowstorm, far less than a thick fog. The rings look solid from a distance because there are billions of particles spread across a surface area large enough to collectively reflect enormous amounts of sunlight, and because perspective compresses them into a single visual plane when viewed from far enough away. The solid appearance is an artifact of scale and angle, not of the rings themselves. The main ring system spans roughly 280,000 kilometers in diameter. That is more than 2/3 of the distance from Earth to the Moon. And yet those rings are, in most places, somewhere between 10 and 100 meters thick. Think about that ratio carefully. 280,000 kilometers wide, 100 meters thick. If you scaled that down, if you made the rings the width of a basketball court and maintained the same proportions, their thickness would be roughly the width of a human hair. What looks, from Earth, like a solid disk with apparent depth and volume is, in its actual physical proportions, one of the flattest structures in the solar system. Proportionally thinner than a sheet of paper pressed flat. That thinness is not accidental. It is the result of the same orbital physics that organized the particles into rings in the first place. Particles that orbit Saturn at slightly different orbital inclinations collide with each other. Each collision nudges them slightly. Over millions of years, those nudges average out in a way that pushes all the particles toward the same orbital plane. The rings self-organize into their thin, flat shape, not because anything arranged them, but because orbital mechanics and billions of years of low-velocity particle interactions drive everything toward that equilibrium. The particles in the rings are not drifting gently. They are moving at the speeds required to maintain their orbital distances from Saturn, tens of thousands of kilometers per hour at the inner edge of the ring system. From Earth, the rings look still. They are not still. They are a continuous field of fast-moving objects, each one following its orbital path, each one interacting subtly with the particles nearest to it. The beautiful, still image is the long exposure average of something in constant motion. And the question of where all this material came from, what produced this field of billions of orbiting ice particles in the first place, requires understanding something about Saturn's gravity that permanently changes how the rings look. The rings are evidence of something that no longer exists. There is also something to be said about what the rings reveal when you look at them with the Roche limit in mind. The visible rings have structure. They are not uniform. There are gaps, variations in density, waves, and organized patterns within the ring system. Many of these structures are produced by gravitational resonances with Saturn's moons. A moon orbiting outside the rings can, if its orbital period has a simple mathematical ratio to the orbital period of ring particles at a certain distance, consistently push those particles onto slightly different orbits. Over time, this preferential pushing clears out a gap in the rings, or creates a density wave. This means the rings are not only a record of past destruction, they are an ongoing system, continuously being shaped by Saturn's moons through gravitational influence. The moons organize the rings. The rings in turn exert tiny gravitational influences back on the moons. The whole system is in conversation with itself, slowly through gravity. The beautiful flat disk is not static debris. It is an active system, every part of it in motion, every part of it interacting with every other part through gravity, every part of it slowly changing in ways that will produce a different configuration over millions of years. Saturn built its rings through destruction. And then, through the complex gravitational interactions of the ring particles with each other and with the moons. It keeps sculpting them into new configurations continuously. There is something else the ring system tells you about Saturn, beyond what it is made of and where it came from. The rings are in motion not just in the sense that their particles orbit Saturn, but in the sense that the ring system as a whole is dynamically evolving. The shapes of the rings, the locations of the gaps, the density patterns are all changing slowly. Gravitational resonances with moons shift particle orbits over time. Collisions between particles redistribute material. The ring rain removes mass from the inner rings continuously. The whole structure is a slow motion process, not a fixed object. Seeing the rings as a process rather than a structure changes what the beautiful image represents. The smooth, flat, luminous disk in the telescope is not a static thing. It is a snapshot of an evolving process. The disk you see tonight is not the disk that existed 1,000,000 years ago, and it will not be the disk that exists 1,000,000 years from now. The changes are slow, imperceptible on any human timescale, but they are continuous and real. What you are looking at when you look at Saturn's rings is not a ring. It is a ring system at this particular moment in a long history of formation, evolution, and gradual disappearance. Every moment of observation is a different moment in that history. The beautiful oval in the telescope is the ring system as it happens to exist tonight, briefly stable from the perspective of a human lifetime, but continuously changing from the perspective of the solar system. The image captures one frame of a very long film. Understanding why requires understanding the exact mechanism that removed it. There is a boundary around Saturn. It is invisible. It has no physical marker. No instrument could detect it directly by flying through it. No particle in the rings knows it is there. But it is real, defined entirely by the mathematics of gravity, and on one side of it, objects can hold themselves together, and on the other side, they cannot. This boundary is called the Roche limit. Understanding what produces it requires one specific insight about gravity that is easy to overlook in everyday experience. Gravity does not pull all parts of an object equally. When Saturn exerts gravitational force on a moon orbiting near it, Saturn does not pull the moon as a single unit with a single force. Saturn pulls the near side of the moon harder than the far side. The near side is closer to Saturn and feels a stronger gravitational tug. The far side is further away and feels a slightly weaker one. This difference in gravitational pull between the near side and far side of a single orbiting body is called a tidal force. The word tidal is familiar from Earth's oceans. Earth's tides are produced by the same principle. The moon pulls slightly harder on the near side of Earth than on the far side, and this difference stretches Earth's oceans slightly toward and away from the moon, producing the tidal bulges that cause ocean tides. The same physics, operating at a much more extreme scale, is what happens inside the Roche limit. At large distances from Saturn, the tidal force on any orbiting object is small. The difference in gravitational pull between the near side and far side of a moon is much less than the internal forces holding the moon together. The moon does not register the asymmetry as stress. It holds its shape without difficulty. But as the moon moves closer to Saturn, the tidal forces grow. Not linearly, the gravitational force between two objects increases with the inverse square of the distance between them, so as the moon moves closer, the difference in pull between near side and far side grows rapidly. At a certain distance, that difference becomes comparable to the internal forces holding the moon's material together. At an even closer distance, the tidal force exceeds those internal forces. Think of a wet sponge being pulled from both ends. Gentle pressure and the sponge holds its shape, deforming slightly at the centre but staying together as a whole. Apply enough force and the material at the centre can no longer hold the two halves together. The sponge tears. Not because anything is wrong with the sponge, because the pulling force has exceeded what the material can bear. Saturn's tidal gravity is pulling from both ends of any object that orbits within range. The near side is accelerated slightly towards Saturn. The far side is pulled less strongly and falls slightly behind. The object stretches along its orbital path. If the stretching force exceeds the internal cohesion of the material, the object breaks apart. The fragments spread along the orbital path, collide with each other, break into smaller pieces, and gradually organize into the flat disk that orbital mechanics favors. Saturn's Roche limit for typical icy material sits at roughly 147,000 kilometers from Saturn's center. Saturn's main ring system extends to roughly 140,000 kilometers from Saturn's center. The rings exist almost exactly within the Roche limit. This is not coincidence. It is the reason the rings exist there and not elsewhere. Inside the Roche limit, material cannot form a stable, gravitationally rounded body. Any object large enough for its own gravity to pull it into a sphere that crosses this line will be gradually disassembled by tidal forces. The fragments spread out along the orbital path. They interact, collide, break into smaller pieces, and over time settle into a thin disk. The rings are what you get when moon-sized objects, or large icy bodies, or captured objects from the outer solar system, enter the Roche limit and do not survive it. They are evidence of things that no longer exist as complete objects. Every particle drifting in Saturn's rings was once part of something larger. That larger object is gone. Saturn's gravity took it apart. The pieces remained in orbit, and over hundreds of millions of years, orbital mechanics organized them into the beautiful thin flat structure that made Saturn the most recognizable planet in the sky. The elegance is real. The origin was not gentle. Saturn's most recognizable feature is a visible record of tidal dismemberment, spread across a region of space where the same gravity that destroyed the original objects prevents anything from ever reassembling into a moon again. The rings are beautiful because they are destruction, organized by the thing that caused it. The ring rain process also connects back to the metallic hydrogen layer in an interesting way. The magnetic field generated by the metallic hydrogen layer is what provides the pathways that ring rain follows. Without the magnetic field, the charged particles from the rings would not be guided toward the atmosphere. They would remain in orbit until other processes removed them, which would likely mean a slower overall drain rate. The metallic hydrogen generates a magnetic field. The magnetic field guides charged ring particles into the atmosphere. The rings drain. The interior is connected to the rings not just through gravity, but through electromagnetism. Saturn is a system where the deepest interior and the most visible exterior are connected by invisible physical forces. The metallic hydrogen layer, tens of thousands of kilometers below the cloud tops, is actively participating in the disappearance of the rings that make Saturn beautiful from 1 billion kilometers away. The interior and the rings have never been separate. They have always been part of the same ongoing process, linked by the physics of a magnetic field generated by a metal that should not exist. That connection has been running silently the entire time the rings have been there. The timescale of the rings' disappearance is worth sitting with in the context of the solar system's overall age. The solar system is roughly 4.5 billion years old. 100 to 300 million years is between 2 and 7% of the solar system's total age. On a cosmic timescale, That is brief. Not negligible, but brief. The rings would exist for a relatively small fraction of the solar system's total lifetime. Compare this to something like Earth's oceans, which have been present in some form for most of Earth's history, more than 3 billion years. Or to the Moon, which has orbited Earth for about 4.5 billion years. These are features that have persisted for most of the solar system's existence. They feel permanent in a way that the rings do not, if you accept that the rings are as young and as temporary as current evidence suggests. Saturn itself is 4.5 billion years old. The rings in their current form may be 100 million years old. Saturn is 45 times older than its own rings. The planet that the rings decorate has been there, and been recognisably Saturn in terms of its mass and its gas giant nature for the entire history of the solar system. The rings showed up recently. In a few 100 million years, they will be gone. Saturn will continue. The rings are a recent and temporary feature of an ancient planet. The image we associate with Saturn, the image that made it the most recognisable planet in the sky, may be characteristic of only a few % of Saturn's total existence. And Saturn is not done with what it has produced. The rings are disappearing. Not quickly, not visibly, not in any time frame a human lifetime could observe directly, but measurably, continuously, and in a direction that does not reverse. The process is called ring rain. To understand it, start with what the ring particles are exposed to. The particles in Saturn's ring system are not isolated from the rest of Saturn's environment. They are continuously bathed in ultraviolet radiation from the Sun and in the flow of charged particles that moves through Saturn's magnetosphere. This radiation and these charged particles interact with the surfaces of the ring particles. In particular, they give the smallest and lightest ring particles an electrostatic charge. Charged particles in a magnetic field do not simply continue in straight lines. They respond to the magnetic field. They curve and follow the field lines. Saturn's magnetic field lines run from the deep interior of the planet, outward through the rings, through the space around Saturn, and back into the planet at the poles. A small charged particle in the ring system that has been given an electrostatic charge by radiation or the magnetospheric particle flow will begin to follow one of these field lines. It will arc away from the ring plane, travel inward toward the planet along the magnetic field, and eventually descend into Saturn's upper atmosphere. It becomes part of the planet it was orbiting. This happens continuously, not in visible showers or dramatic events. The ring rain is invisible, steady, and relentless. Particle by particle, hour by hour, the rings are losing mass to Saturn's atmosphere through this electromagnetic drain. The Cassini spacecraft, during its years in orbit around Saturn, measured this process. Scientists analysing the data estimated that Saturn's rings are losing material at a rate that, if sustained, would drain the main ring system within somewhere between 100 and 300 million years. That range is wide, because the process involves genuine uncertainties and the rate may vary over time. Future observations and models will refine the estimate. But even at the most conservative end of that range, the rings are finite. They are not eternal. They have a lifespan, and by solar system standards, that lifespan is not long. And there is something else about the rings that complicates the impression of permanence even further. The rings may not be ancient. Based on analysis of the ring material, the mass of the ring system, and the way the particles interact with Saturn's magnetic environment, a number of planetary scientists have concluded that Saturn's rings as we see them today are relatively young by solar system standards. Some estimates place the age of the current ring system at somewhere between 10 million and 100 million years. if that estimate holds, the rings were not there when the first dinosaurs appeared on Earth. They formed during a period when recognizable animals were already walking on land here. They appeared in what is, in the full 4.5 billion year context of the solar system, a very recent window. Before this window, Saturn looked different from how it looks today. Without its current rings, or with a much different ring configuration, the most visually distinctive object in the solar system had not yet taken the form we know. After this window, Saturn will look different again. The ring material will have drained back into the planet through ring rain, dispersed into space through other processes, or both. The glowing ring that has been reproduced in every astronomy textbook and on every classroom wall since telescopes were invented will be gone. We were born into a specific narrow window during which the rings happen to exist in their current form. 100 million years from now, whatever is here to observe the solar system will see Saturn without its rings. Still enormous, still pale gold, still generating more heat than it receives from the sun, still running its hexagon at the North Pole and its jet streams at the equator. But the ring will be gone. The thing that made Saturn instantly recognizable will have dissolved back into the planet that created it. The rings are not a permanent feature of Saturn. They are a phase, a configuration that happens to exist right now in this specific window of Saturn's long history. We are watching them in the middle of that phase. We are watching them disappear, slowly and steadily and invisibly, without being able to see it happen. There is also a larger pattern worth naming in what Enceladus represents. Saturn did not place the ocean in Enceladus deliberately. It did not plan the plumes or design the chemistry of what they contain. What happened is that Enceladus orbited in a specific position, at a specific distance, in an orbital path that happened to be slightly elliptical due to resonances with other moons. And the physics that follows from that configuration produced a moon that is internally active, liquid, and erupting. The conditions produced the outcome, not intent, not design, just physics applying consistently to the situation that existed. The reason this matters is that it suggests Saturn's gravitational system is capable of producing liquid water environments without meaning to, as a side effect of the ordinary mechanics of gravity acting on orbiting bodies. Enceladus is not the only small moon in the solar system with a subsurface ocean. Several moons in the outer solar system appear to have liquid water layers maintained by similar tidal processes. This suggests that the outer solar system, which looks from a distance like a collection of cold, dead ice balls, may contain liquid water environments more broadly than was assumed before the Cassini era. Saturn produced one of those environments inadvertently through the simple application of gravity to an orbiting moon. The violence that created the rings and the conditions that maintain Enceladus's ocean both come from the same force. Destruction and something closer to preservation, both products of the same gravitational field operating at different distances and in different modes. Enceladus also raises a question about what Saturn's gravitational influence means for the possibility of environments capable of supporting life. Earth has long been considered the only place in the solar system where conditions suitable for life as we know it exist at the surface. The conditions include liquid water, a source of energy, and the chemical building blocks that biology uses. Earth has all of these at the surface, powered by the sun. Enceladus has liquid water. It has an energy source, Saturn's tidal heating. Cassini detected organic compounds and hydrogen in the plumes, consistent with the kind of hydrothermal chemistry that occurs in Earth's deep sea vents where life thrives without sunlight. None of this confirms that life is present in Enceladus's ocean. but it confirms that the conditions that on Earth support life are present in that ocean. Saturn did not intend to create this. The tidal heating is a mechanical consequence of orbital mechanics. But the consequence is an environment that, by the criteria scientists use to evaluate habitability, has what it would need. A small, frozen moon more than 1 billion kilometers from the Sun, in an environment that looks from a distance like one of the most inhospitable places imaginable, contains an ocean that might, by the same chemical logic that applies on Earth, be capable of supporting something. That possibility exists because Saturn's gravity heats the moon's interior. The violence of Saturn's gravitational influence, which destroys things inside the Roche limit and reshapes everything it touches, also keeps this small moon's ocean from freezing. The same force. 2 outcomes. At different distances. And just beyond the outer edge of the disappearing ring system, in orbits safely outside the Roche limit, Saturn's moons circle. They are outside the zone of tidal dismemberment. But Saturn has not left them alone either. Enceladus should be frozen. Every straightforward calculation says so. Enceladus is a small moon, roughly 500 kilometers in diameter. A moon that's small, orbiting at Saturn's distance from the Sun, with no obvious large-scale internal heat source, should have cooled completely billions of years ago. Small objects lose heat faster than large ones, because they have more surface area relative to their volume. The ice that makes up most of Enceladus should be rigid and permanent. The geology should be long dead. The surface should be old, uniformly cratered by impacts accumulated over billions of years, frozen and unchanged since the early solar system. Enceladus is erupting. From its south pole, columns of material shoot into space. Water vapor, ice particles, organic compounds including some of the chemical building blocks that life's chemistry uses on Earth. Molecular hydrogen, produced by chemical reactions that require liquid water in contact with warm rock at the right temperature. Sodium chloride, the same salt that gives Earth's oceans their characteristic taste. All of it rising from the surface of a moon that by all rights should have nothing warm enough to produce any of it, and spraying outward into the space around Saturn at several hundred meters per second. The Cassini spacecraft flew directly through these plumes on multiple occasions, deliberately targeting them for close analysis. The instruments measured the composition of the ejected material in detail. The chemical inventory detected water, salts, organic molecules, hydrogen produced by hydrothermal chemistry is the kind of inventory that on Earth describes the environment near deep-sea hydrothermal vents. Those vents, where superheated water meets cold ocean water at the base of Earth's oceans, support thriving communities of life that do not depend on sunlight. The implications of that parallel for the question of life in the outer solar system belong to a different and longer conversation. The point here is more immediate. Where is the heat coming from? The answer is Saturn. Specifically, Saturn's gravity, operating not through distance, but through the changing strength of its gravitational pull as Enceladus moves along its orbit. Enceladus orbits Saturn in a path that is not a perfect circle. It is slightly elliptical. This means that Enceladus's distance from Saturn changes as it moves around its orbital path. When it is at the closer end of its orbit, Saturn's gravity pulls on it more strongly. When it is at the farther end, the pull is slightly weaker. This continuously varying gravitational force acts on the entire body of the Moon, not on its surface, but through its entire interior. Think about what happens when you repeatedly bend a metal wire back and forth. The wire heats up, not from any external heat source, from the work being done against the material itself as it is deformed and released. deformed and released, over and over. The energy of bending is converted into heat inside the metal. This is a simple physical principle that applies to any material that flexes under applied stress. Enceladus is the wire. Saturn's changing gravity is what bends it. Every orbit, as Enceladus moves closer to Saturn and then farther away, the Moon is squeezed and released by the varying tidal force. The near side is pulled slightly more than the far side when Enceladus is close. The whole body flexes. The flexing produces heat inside the Moon. That heat builds in the interior, melts the ice that would otherwise be permanently frozen, and sustains a liquid water ocean beneath the ice shell. The ocean is real. Multiple lines of evidence from Cassini confirmed it. Gravity measurements, magnetic field data, the chemical content of the plumes themselves. A liquid water ocean exists beneath the icy surface of Enceladus, kept from freezing by the continuous tidal heating provided by Saturn's gravity with every orbit. The ocean finds its way to the surface through fractures in the ice shell at the South Pole, where the shell is thinnest or most stressed. The water and gas and particles erupt through these fractures. The plumes are the ocean reaching space. And the material that Enceladus ejects does not simply disperse and vanish. It follows Saturn's orbital dynamics and magnetic field into a faint, diffuse ring, Saturn's E-ring, one of the outermost features of the ring system. The E-ring is partially made of ocean water from Enceladus, erupted into space by tidal heating, organized into a ring by Saturn's gravity and electromagnetic structure. Saturn destroyed the objects inside the Roche limit. Their remains became the main rings. Saturn heats a moon outside the Roche limit. The overflow from its ocean becomes a faint outer ring. Both processes. Both producing rings, both driven by the same force, operating at different distances and in different modes. The violence and the strange preservation are the same thing, seen from different orbital distances. The Mimas impact also illustrates something broader about the environment Saturn creates. The inner solar system in general is a place where collisions happen. Objects on crossing orbits will eventually meet. The history of every moon and every rocky body in the solar system is written partly in its craters, which are the physical record of those meetings. Some meetings are small, leaving minor scars. Some are large enough to reshape the body they hit. Some are large enough to destroy it. Saturn's inner moon system is not isolated from this general process. The objects in Saturn's orbital neighborhood have been interacting with each other for billions of years. Mimas orbits in a region where it has been subject to this environment for the full history of the solar system. The Herschel impact was one event in a much longer sequence of events. What Mimas survived is not unusual in type. It is unusual in scale relative to the size of the target. The crater is so large relative to the Moon that it stands as a record of a near miss with destruction, rather than simply a record of a collision. Most craters on most moons are clearly survivable impacts. Herschel crater is at the edge of that category. It is the closest thing in the visible solar system to a moon wearing the proof of how close it came to not existing at all. The Mimas story also illustrates something about how the solar system's history is written in objects rather than in records. On Earth, humans keep records. We write things down. We photograph events. We store information about what happened and when and how. The historical record is something maintained deliberately, updated continuously, and preserved intentionally. The solar system keeps its own records. But they are written in surfaces, in craters, in orbital dynamics, in the composition of atmospheres and oceans and rings. Herschel crater is a record of an event that happened a very long time ago, preserved in the ice of Mimas, readable by anyone who can interpret what a crater of that size on a moon of that size means. The interpretation tells you the size of the impactor, the energy of the collision, the structural response of the moon, and the relationship between the event and the moon's survival threshold. None of that required a witness. None of it required a recording device. The crater itself is the record, encoded in the physical shape of the moon, preserved for billions of years because ice in the cold outer solar system has no erosion, no weather, no processes that would erase it. Mimers will carry that record for as long as it exists. If something eventually destroyed Mimers, the record would be lost. But as long as Mimers orbits Saturn, the crater is there. The event that produced it is preserved not in any database or library, but in the physical reality of the moon that survived it. The solar system is its own archive. Nothing within Saturn's gravitational reach remains unchanged by it. Mimas is not one of Saturn's famous moons. It does not have a thick atmosphere. It does not erupt geysers into space. It does not have liquid lakes or evidence of active chemistry or any feature that has attracted sustained scientific attention over recent decades. Mimers is a roughly spherical object of ice and rock, approximately 396 kilometers in diameter, orbiting Saturn in the inner portion of the Moon system. Small enough that if you placed it over the continental United States, you would need less than half the country to contain it. It orbits close to Saturn, inside the orbits of the more dramatic moons, and in most discussions of Saturn's system it is mentioned briefly, if at all. But Mimers carries something that no other moon in the inner solar system displays so dramatically. A crater. Not a small one, not one of the many ordinary impact scars that accumulate on any airless body over billions of years of exposure to space debris. A crater so large that when scientists first saw Voyager images clear enough to identify it clearly, the visual effect was arresting. The moon appeared to have an eye. Herschel crater measures roughly 130 kilometers in diameter. On a moon 396 kilometers across, that is a crater covering approximately 1/3 of the total visible diameter of the moon from the side facing the impact. The walls of the crater rise roughly 5 kilometers above the surrounding terrain. At the center, there is a peak approximately 6 kilometers tall, formed by the rebound of material that was briefly made fluid by the energy of the impact and then solidified in place as that energy dissipated. The walls, the floor, the central peak, the overall scale of the feature relative to the moon on which it sits, give the moon an appearance unlike any other object we have documented in the solar system. The impact that produced Herschel was not a surface event, it was a global one. The energy released by the collision sent seismic waves through the entire body of Mimers, not just the surface near the impact site. The entire moon. The waves travelled through the ice and rock of the interior in every direction simultaneously. On the side of Mimers directly opposite the crater, the disrupted terrain is consistent with those seismic waves converging after travelling through the planet's interior and releasing their remaining energy on the far side. Mimers shook as a single object because of what hit one part of its surface, and the moon survived it. But the survival was not certain. The impactor that produced Herschel crater was, by the calculations of impact physicists working from the crater dimensions and the physical properties of the target, close to the threshold of what Mimers could absorb and remain intact. A somewhat larger impactor, or the same object moving somewhat faster, would not have produced a crater. The energy released would have exceeded what the internal cohesion of the moon could absorb and disperse. The moon would have broken apart. The fragments would have spread along Mimers' orbital path. Some of them, over time, might have drifted inward and crossed the Roche limit, joining the ring system as new particles. Mimers, as a recognizable moon with a surface and an orbit, would have ceased to exist. It would have become ring material. There is a version of this story where that happened, where the impactor was just slightly larger, or just slightly faster, and Mimers does not exist, and the ring system contains slightly more material of a specific origin. We are living in the version where the margin held. The crater is the proof that the margin existed. Its size tells you approximately how large the impactor was, and approximately how much energy was released. The fact that Mimers survived tells you that the energy was just below the threshold. The gap between survival and destruction for Mimers was real and was close. Saturn's inner moon system is not a stable, protected environment where moons orbit undisturbed. It is a region shaped by billions of years of orbital dynamics, gravitational interactions, and the occasional high-energy collision. The surfaces of the moons that orbit within it record the history of that environment. Mimers records it more dramatically than almost anything else in the inner solar system. The crater proves that the objects of Saturn's inner moon system survive not through protection from their environment, but through contingency within it. There is one more thing about Titan that connects back to the larger story. Titan's thick nitrogen atmosphere is something scientists are still trying to fully explain. One contributing factor that has been studied is Saturn's magnetosphere. Titan spends most of its time inside Saturn's magnetosphere, which is the region of space dominated by Saturn's magnetic field. The magnetosphere deflects some of the solar wind that would otherwise interact directly with Titan's upper atmosphere and gradually erode it. The protection is not complete, but it is real. Saturn's magnetic field, generated by metallic hydrogen in the planet's deep interior, may therefore be one of the factors that allowed Titan to retain an atmosphere thick enough to support methane rain and lakes and the complex atmospheric chemistry that gives the moon its orange colour. The metallic hydrogen layer connects to the magnetic field, which connects to Titan's atmospheric retention, which connects to the rivers and lakes on Titan's surface. An element compressing into a metal tens of thousands of kilometres below Saturn's cloud tops may be part of the reason a moon more than 1 billion kilometres from the Sun has weather. Saturn is not a collection of separate independent features. It is a system, every part of it connected to every other part. The violence in one place, the strange preservation in another, the beauty visible from Earth, all of it traceable back to the same underlying physics, operating at a scale that makes the image in the telescope the smallest and least representative thing about it. The methane cycle on Titan also offers something that Earth's water cycle does not offer in the same way. Earth's water cycle is ancient. It has been running in roughly its current form for billions of years. The specific rivers and the specific lakes change, but the cycle itself, evaporation and precipitation and drainage, has been continuous. We have no record of it beginning. It has simply always been there, within human memory and written history and the geological record as far back as the evidence goes. Titan's methane cycle may have a different relationship with time. Methane in Titan's atmosphere is being continuously broken down by ultraviolet radiation into more complex organic compounds, which rain out of the atmosphere as the orange-brown haze that covers the moon. If methane is being destroyed in this way, it needs to be continuously replenished, or the methane inventory will eventually be depleted and the cycle will change or stop. Where the methane replenishment comes from is still an open question. There may be methane reservoirs underground. There may be geological processes releasing methane from the subsurface. The cycle may have been intermittent through Titan's history, running during periods of active methane supply and pausing when supply is interrupted. The rivers and lakes and rain on Titan may not be a permanent feature in the way Earth's water cycle is a permanent feature. They may be a phase, dependent on a supply of methane that has its own history and its own future. The methane seas could dry up, the rain could stop, the rivers could go quiet. Or not. The uncertainty is genuine. What is certain is that right now, at this moment, they are there. Rivers are running on Titan. The methane is cycling. The orange clouds are producing rain. Whatever the future of the cycle holds, it is happening now, in the shadow of Saturn, more than 1 billion kilometers from the Sun, and beyond the inner moon zone, in a wider orbit that has given it more distance from Saturn's most intense gravitational effects, there is a moon that built something no other moon in the solar system has managed to replicate. Titan should not have an atmosphere. The logic is well established, and the calculation is simple. Small bodies do not hold atmospheres well. Gravity on a small world is weaker, which means atmospheric molecules at altitude can reach escape velocity more easily and drift away into space. Over billions of years, small bodies exposed to solar radiation and the solar wind gradually lose whatever atmospheric gas they began with. Mars, substantially larger than Titan in diameter and much closer to the Sun, has lost most of its original atmosphere. What remains on Mars is so thin that the atmospheric pressure at the Martian surface is less than 1% of Earth's. Titan is smaller than Mars. Titan's atmosphere is thicker than Earth's. The surface pressure on Titan is roughly 1.5 times the atmospheric pressure at Earth's surface at sea level. The atmosphere is predominantly nitrogen, the same gas that makes up about 78% of Earth's own atmosphere. It is thick enough and hazy enough from photochemical reactions in the upper layers that produce a characteristic orange-brown smog of organic aerosols. But the surface of Titan cannot be directly imaged from orbit through ordinary optical cameras. When the Huygens probe entered Titan's atmosphere and descended toward the surface, it spent roughly 2.5 hours falling through that atmosphere before the ground appeared below. The atmosphere was present the entire descent and was still thick near the surface. The reasons for Titan's atmospheric survival involve multiple factors. The temperature at the top of Titan's atmosphere is cold enough that most atmospheric molecules move too slowly to reach escape velocity. Saturn's magnetic field provides some protection from the solar wind that strips atmospheric gas from unshielded bodies. The photochemical reactions in the upper atmosphere produce certain heavier organic molecules that are harder to lose than lighter compounds. The full explanation for how a moon of Titan's size has retained this atmosphere for billions of years is still being studied and refined. What the atmosphere produces is known, measured, and deeply strange. Titan rains. Not water. The surface temperature on Titan is approximately minus 179 degrees Celsius. At that temperature, water has been solid for the entire history of the solar system at Saturn's orbital distance. Water ice on Titan is not a liquid, it is bedrock. As rigid and hard as granite under normal Earth conditions, but made of water ice instead of silicate rock. The surface of Titan is partly composed of water ice in this solid form, used by Titan's geology the way rock is used by Earth's. But methane, a molecule of 1 carbon and 4 hydrogen atoms, has a freezing point far below what Titan's surface temperature reaches. Methane can be liquid at Titan's conditions. And on Titan, methane does what water does on Earth. It evaporates, it enters the atmosphere, it forms clouds in the upper atmosphere where temperatures drop further, it precipitates, it falls. Methane rain falls on Titan's surface. It flows across the ground in rivers. The rivers carve channels into the ice and organic material of the surface, following topographic gradients exactly the way water rivers do on Earth, because the physics of drainage is the same regardless of what the liquid is. The channels drain into lakes. Near Titan's poles, the lakes expand and deepen into seas. The largest estimated sea, Kraken Mare, has a surface area estimated from radar imaging at larger than Earth's Caspian Sea. The liquid below its surface may be hundreds of meters deep in places. Lakes of liquid methane, rivers of liquid methane. Methane rain falling from orange clouds onto an icy surface and flowing downhill in drainage networks that look, in Cassini's radar images, strikingly similar to river basins and drainage systems on Earth. The geography is familiar in shape, the material is not. This is what physics produces when the right conditions align. A liquid that evaporates, condenses into clouds, precipitates and drains back into a collection basin will produce rivers and lakes and drainage systems wherever it exists, regardless of what that liquid is chemically. On Earth, the liquid is water, the temperature is habitable, and the chemistry supports biology as we know it. On Titan, the liquid is methane, the temperature is far below what life needs, and the chemistry is entirely different. But the shapes are recognizable because the underlying physics of drainage is the same. Titan built all of this in the shadow of Saturn, in an orbit stable enough to persist through billions of years of Saturn's gravitational influence, in a position where Saturn's magnetic field offers partial protection from the solar wind. Shaped by a gravitational environment that also tore apart the ring material, heats Enceladus from the inside, and left Mimas carrying the scar of a near-fatal collision. Saturn's gravitational neighbourhood does not do one thing, it does everything. It destroys at close range, it heats and pressurizes at medium range. It allows stability at greater distances, and in that stability, given enough time, worlds as strange as Titan can form. The same force. Different outcomes. Different distances, different timescales. There is also a simpler way to frame what Titan is. Every world in the solar system that humans have studied up close has turned out to be more complex than the initial image suggested. Mars looked dead and then revealed ancient river valleys and polar ice, and a thin atmosphere carrying dust storms that cover the whole planet. The Moon looked featureless, and then revealed a complex geological history of impacts and volcanic flows, and a magnetic field that no longer operates but once did. Europa looked like a smooth icy shell, and then revealed evidence of a liquid ocean underneath it large enough to contain more water than all of Earth's oceans combined. Titan fit this pattern, but exceeded it. From a distance, Titan was a moon with an atmosphere. Unusual, but not obviously extraordinary. When Cassinian Huygens arrived and the atmosphere was penetrated and the surface was imaged through radar, what appeared was not a featureless ice ball with weather. What appeared was a world with geography, with drainage basins shaped by flowing liquid, with dunes built by wind, with a North Pole covered in seas, a world in the fullest sense of that word. Not habitable in any way familiar, not warm, not water-bearing at the surface, not a place that would support human life or any life that evolved in the conditions of Earth's biosphere, but organised, complex, structured by processes that, though they involve alien chemistry at alien temperatures, follow the same physical logic that organises Earth's surface. Titan is what you get when physics applies its consistent rules to an environment that is nothing like Earth and produces something that resembles Earth in outline, because the rules are the rules regardless of the planet. It is one of the stranger outcomes in the solar system, and it exists here, in Saturn's system, shaped by the same gravitational presence that tore apart the ring material and heats Enceladus and left Mimas carrying its impossible crater. All of it Saturn. Come back to the beginning. The telescope. Saturn, small, still pale gold. the ring tilted just slightly, catching the light, the image that made people stop the first time they saw it, and that has not stopped making people stop since. That image has not changed. It will not change by the end of this. Saturn looks exactly like this tonight, from any telescope pointed at the right part of the sky. The rings still glow, the gold still holds. The whole thing still looks, at this distance and through this lens, like something designed to be looked at. Beautiful in a way that seems deliberate. Peaceful in a way that seems permanent. But the image means something different now. The pale gold is the top of an atmosphere that never stops moving. The clouds visible even at this distance are the upper surface of a wind system that moves more than 4 times faster than the fastest wind ever recorded on Earth's surface. Not during a storm, not during a record event, but as the normal, permanent, continuous baseline of what that atmosphere does. Every hour, every day, without interruption, without anything resembling a still morning or a calm period, without the kind of quiet that exists on Earth, because Earth has terrain to absorb and slow and organize the atmospheric energy flowing through it. Saturn has no terrain. The energy circulates indefinitely. Below those clouds, the atmosphere continues downward without a flaw. There is no surface beneath the rings. No ground. No arrival. Just increasing pressure and increasing heat, layer by layer, until at a depth far below any point a spacecraft has directly measured, the hydrogen stops being gas and becomes something with no ordinary name, something that conducts electricity, something that generates the magnetic field extending millions of kilometers into the space around the planet. The ring is not calm. The ring is a field of billions of individual particles, each one in its own fast orbital path, each one slowly losing energy through collisions and through the electromagnetic drain of charged particles following Saturn's magnetic field lines back into the atmosphere. Each one part of a structure that is feeding back into Saturn at a measurable rate. The ring is temporary. The window during which it exists may be among the shorter features of Saturn's long history. We are seeing it now, at this particular moment, and the moment will eventually close. And surrounding the ring system, the moons. Enceladus, far too small to have remained geologically active on its own at this distance from the Sun, kept liquid inside by Saturn's tidal gravity, erupting its subsurface ocean through fractures in its south polar ice and spraying water into the space around Saturn. The water feeds a faint outer ring. The moon that should have been frozen for billions of years is one of the most geologically active objects we know of in the solar system, powered entirely by the gravity of the planet it orbits. Mimas, carrying a crater that covers a third of its face, the permanent record of a collision that came close enough to the survival threshold that the outcome was genuinely contingent. A moon that exists because the impactor was just small enough. The crater is not the damage from something Saturn did. It is damage from the orbital environment Saturn's gravity created, the population of objects it influences and that occasionally intersect with each other. Titan, sitting in its outer orbit beneath an orange nitrogen sky, with methane rain falling on methane rivers draining into methane seas, a world that organized itself into something geographically familiar and chemically alien over billions of years, in the shadow of a planet that was doing enormous and ongoing things to everything around it. All of this is Saturn. This is what the telescope image contains, compressed by distance into a glowing oval with a ring. The question at the beginning of this story was whether Saturn is actually scary, and what that word means when the thing being described is more than 1 billion kilometers away and poses no direct threat to any human being. Here is the answer. Scary does not have to mean threatening. It can mean operating at a scale and by a physics that has no human equivalent anywhere in its range, and that produces no environment a human could survive direct contact with. It can mean that the beautiful thing you are looking at is beautiful precisely because of the violence that produced its appearance, and that continues to shape it. It can mean that the permanent glowing ring you see through the lens is the organized remains of things that were pulled apart by gravity, that the gold atmosphere hides a permanent catastrophe of wind that never quiets, that the interior contains matter in states that the most sophisticated laboratories on Earth can produce only for fractions of a second. Saturn is scary in the way that things become scary when you understand them, not because they are threatening, because they are real, because they are operating continuously by their own rules at a scale where beauty and destruction are not opposites. They are the same process seen from different distances. The rings are beautiful because they are debris moving at orbital speed. The gold atmosphere is beautiful because it is a permanent storm system whose baseline exceeds Earth's worst weather by a factor of 4. The hexagon at the North Pole is beautiful because it is the stable geometric output of fluid dynamics operating at planetary scale, drawn not by any instrument, but by physics itself into the atmosphere of a rotating gas world. The moons are strange and marked, and in some cases unexpectedly active, because Saturn's gravity does not leave anything in its reach unchanged. Enceladus is liquid inside because of it. Mimas bears its crater because of the collision environment Saturn's influence created. Titan became a world with rivers and rain because it found a stable orbital distance and was given billions of years for the conditions to develop. All of it is beautiful. All of it is violent. The two things were never in conflict. They only appeared to be in conflict because the image was not complete. Now the image is complete. And what is complete is this. The calm you see when you look at Saturn is not Saturn. It is distance. It is the compression, by 1 billion kilometers of empty space, of ongoing destruction and creation and heating and organizing and draining, reduced to something that looks still, something that looks designed, something that looks peaceful. Saturn itself has never been still. It has been doing all of this the entire time behind the image that made everyone who saw it stop and look. Good night.